As you're performing your rotations, you're going to have to identify how far they rotated as well as which direction they rotated in. And we measure how far things rotated in how angles are rotated, or degrees. There are 360 degrees in a circle. That means that if you were to perform a full turn and land exactly where you were before, it's 360 degrees. Maybe you've heard of a 360 in skateboarding or in some other sport that has a lot of turns in it. So 360 degrees is a full turn. As we're performing our rotations, we're going to focus mainly on quarter turns, half turns, and 3/4 turns. So in increments of a quarter turn. 360 divided by 4 gives us how much a quarter turn is. 36 divided by 4 is 9. And then there's another 0, so we're going to have 90 degrees for each quarter turn. So our full turn is 360 degrees. A quarter turn is 90 degrees. That means that a half turn is twice as big, or 90 times 2, which is 180 degrees. And a 3/4 turn is 3 times as big as 90 degrees, and 3 times 9 is 27, so 270 degrees. So we're going to do these different turns and identify where things ended up. In this problem, it's 22 because I just picked it from a problem set. We start with triangle ABC, that's this one right here, and it rotates over here to become A prime, B prime, C prime. So I noticed that it moved over one quadrant. This is a really easy way to tell how far it moved. Because it's one quadrant, that means it's 1/4 this way. So that 1/4 means that it's 90 degrees. But we also have to account for the direction that it moved. And we talk about things as either being clockwise or counterclockwise. Clockwise would mean that it moves the same direction as a hand on a clock, or this way. Counterclockwise, of course, will move the other way. I often have to move my finger around like a clock in order to figure out which way it's going. So this one is moving the opposite direction of a clock, so it's 90 degrees counterclockwise. It's also technically going the other way. You could go the other way around the circle and move clockwise, and that would be it'd go over to this quadrant, then this quadrant, then this quadrant. So that's 3/4 of a turn. And we know that 3/4 of a turn is 270 degrees. So when you're talking about how this was rotated, you could talk about it two different ways. You could say it's 90 degrees counterclockwise or 270 degrees clockwise. Let's do number 23 real quick. Our triangle ABC is mostly in this quadrant over here. And then it moves over that away to this quadrant right here. So it is moving one turn, and it's actually moving clockwise. So we know it's going to be 90 degrees because it's only one turn, and it's moving clockwise. Now, if we were to talk about the other way, we'd say that it moved 1, 2, 3 quadrants, so 3/4 of a turn, counterclockwise. And we know that 3/4 of a turn from what we did before is 270 degrees. So basically, anytime you have 90 of one way, it's going to be 270 degrees the other way. Now on this last one, our triangle ABC moves over here. So it moves 2 quadrants. We know that's going to be 180 degrees. If we were to go the other way, we find that it's still 2 quadrants. So it's 180 degrees no matter which way you go. So you actually don't need to specify which way it goes. You can just say it moved and 80 degrees. That's it for today. Good luck.